Welcome back, ladies and gentlemen. The 100th annual Hunger Games are well underway. In this year's Quarter Quell, we're trying something a little different. Girls and guys are fighting to the death in a competition of brains versus bronze. Pairs of the same gender work together to solve complicated math problems and battle it out with difficult obstacles. Right now, we're down to our last girl and boy team. Anu and Poonam have fought valiantly, proving that their brains and cleverness are superior.
Chain rule, must remember chain rule.
Our last pair of boys have fought valiantly as well. To be honest, I'm not sure how they've made it this far. But anyway, our game makers have another difficult challenge for our last two competitors. Both of them are faced with the task of somehow retrieving the shovel from a very tall tree. Let's see how they tackle this task.
There's gotta be a way to get that shovel down without hurting ourselves in the process.
How are we gonna climb this tree? I don't know. Wait, yo! I got it! Come on, come on! Team Rev! Get it!
We can use this to make a slingshot. Here, give me your hair tie. Oh, good idea. Here, thanks. Now what? Well, what could we do with the shovel? Let's dig. But where? Let's start digging underneath this tree. All right. Oh, Anu, look! What is this? Is this a map? No, Poonam, this is so much more than that. I think we finally found a way out. I mean, it's crazy. It looks just like a polar curve. That's what I was gonna say. But what would we do with this map? Well, it says here to find the length of a curve. Oh, darn it! The Hunger Games started before we could finish calc. What are we gonna do? Hey! Oh, looks like our sponsor sent this to us. Oh.
Anu and Poonam, don't mess this up. Don't lose to Team Rovneck. Sincerely, Mrs. Unger.
Why is there a dry erase marker in here? Look behind you! It's another gift from our sponsor! Whoa!
Okay, so let's find this. We have our formula for the length of a polar curve. L is equal to the integral from a to b of the square root of our polar curve squared plus the derivative of our polar curve squared d theta. We're also given that r is equal to 1 minus cosine theta, and our interval is from 0 to 2 pi. So let's start off by finding d theta dr, which is equal to sine theta. And now we're going to substitute this into our formula. L is equal to the integral from 0 to 2 pi of the square root of 1 minus cosine theta squared plus sine theta squared d theta. Now we're going to just evaluate the 1 minus cosine squared. We get the square root of 1 minus 2 cosine theta plus cosine squared theta plus sine squared theta d theta. And now we're going to notice our trig identity here, cosine squared theta plus sine squared theta is going to equal 1. So eventually, with simple algebra modification, we get 2 minus 2 cosine theta d theta. And now I'm going to erase the board. To reiterate once again, L is equal to the integral from 0 to 2 pi of the square root of 2 minus 2 cosine theta d theta. Now we're going to take out a 2 and make it 2 times 1 minus cosine theta. We're going to use some of our double angle formula here. We know that the formula for cosine 2a is equal to 1 minus 2 sine squared a. With simple modification, we get that sine squared a is equal to 1/2 times 1 minus cosine 2a. So now we're going to use our given and use this double angle formula. Once again, the given is 2 times 1 minus cosine theta. And we're going to make it 4 times 1/2 times 1 minus cosine theta. So now we can plug in that sine squared a. Eventually, we're going to get 4 times sine squared theta over 2. So now we're going to put that back underneath our integral. So the integral from 0 to 2 pi of the square root of 4 sine squared theta over 2 d theta. Now we're going to just simply take out the square root and make it 2 sine theta over 2 d theta. And now we're going to take our antiderivative, which is just simply minus 2 cosine theta over 2 divided by 1/2, which becomes minus 4 cosine theta over 2 evaluated from 0 to 2 pi, which is really just 4 plus 4, which gives us 8 miles.
So we have to run 8 miles. It's gotta be here, right? Well, according to my calculations, our antiderivative was perfectly accurate, and who am I kidding? We even used a calculator.
And it must be right.
Poonam and Anu, you have arrived at the final location. It's time to test your skills in a death round of calculus. If you can conquer this problem, the victory will be yours. Send forth your weakest player.
Weakest player? What does she know? Well, now I have to solve a problem on my own. Should have paid attention to Anu when she was doing hers. Find the length of a polar curve.
Alright, let's see if I remember how to do this. Well, I think the formula is L equals the integral from a to b of the square root of the polar curve squared plus the derivative of the polar curve squared d theta. Alright, let's see what we're given. The polar curve is r equals theta, and the interval is from 0 to 1. Seems simple enough. So when I substitute this information, I get the integral of theta squared plus the derivative, which is 1 squared d theta. Now with a little substitution, if I make theta equals tan x, then d theta equals secant squared x dx. Now I want to put this information back into my integral. L equals, now if I change my interval from 0 to pi over 4, where in terms of x, we get tan squared x plus 1 times secant squared x dx. And if I simplify this using a trig identity, I know that tan squared x plus 1 is secant squared x, so I have the square root of secant squared x times secant squared x dx. Okay, so now just to rewrite what I had before, the integral from 0 to pi over 4 of the square root of secant squared x times secant squared x dx. And I know obviously the square root of secant squared x is secant x times secant squared x is secant cubed x dx. And I know that the antiderivative of secant cubed x is 1/2 times secant x tan x plus the natural log of the absolute value of secant x plus tan x, all evaluated from 0 to pi over 4. This all boils down to about 1/2 times the square root of 2 plus the natural log of 1 plus the square root of 2. And when I put this into my calculator, I get approximately 1.1478.
Ha! Poonan, you did it!
I present to you our victors for our 100th quarter quell, Anu and Poonam. So, how was it?
Well, I gotta say, it got pretty heated up in there.
So, we're almost running out of time, and do you have any questions for us?
Well, whatever happened to the boys from District Revnek?
Come on, let's go. Almost there! Come on. No. Oh.